me give you an alternative version of that. X bracket 2 colon len x end bracket. Sorry, Russ. So what that says is, give me the slice of the string whose index starts at 2 and whose index runs up to, but not including, the length of the string. So give me everything that is at least 2 and that is less than this number. So everything, the length of the string is 5, right? So give me x sub 2, x sub 3, and x sub 4. That's what this means. Yes. Yes. Anyone want to predict what this will be? Yes.
Minus 3 to minus 1.
X from minus 3 up to minus 1. So the invariant here is if you, the distance here is equal to the number of characters that you're going to get. So 2 up to 5 is a space of 3. So you're going to get 3 characters. Minus 3 up to minus 1 is also a space of 2. So you should get 2 characters. And I think that those 2 characters should be the minus 3 character and the minus 4 character, which should be L and L.
You mean the minus 3 character, the minus 2 character?
Yes, the minus 3 character and the minus 2 character. Thank you. I don't know what would happen if we did it the other order, but we couldn't see if it was the same thing. So let's just do. Right, so minus 4 to minus 1 is ELL. And let's see if we get an error. Nope, it just says that doesn't make any sense. I'm not going to give you anything.
So then how would you ever get the O using the minus signs?
It's 0. No.
Get the what?
How would you ever get the O of hello if you wanted to use the minus signs?
Or you could do minus 3 just colon, right?
Yep. Okay, so in Python slang in particular, this is called slicing operation. And the reason I spent so much time on it is because you use the exact same syntax to operate on other sequences. So one of the unifying and very appealing features about Python is that as much as possible, you reuse the same type of syntax to redo the same type of thing, even if it's with different data types. Okay, and I'll illustrate what that means in more detail in just a moment. And the way that I'm going to do that is by introducing you to the list. Yes, I typed y equals left bracket 1, comma, 2, comma, single quote red, single quote, comma, single quote blue, single quote, end bracket, enter. Oh, I should have named the list fish. Okay, there's several features that I would like for you to note about this. Okay, one of them is the list uses brackets. So you can actually create a list using the command list, but almost always people use brackets. So the beginning of a list and the end of a list is marked by a bracket in Python, normally. Second thing, the list contains a number of elements. When it's displayed and when it's entered, you normally separate those elements with a comma.
Does it care if you put a space between the comma and the next one or not?
It does not care in the slightest.
So if we typed print fish, we'd get that without the brackets, but with the quotes around red and blue?
No, we would still get the brackets, I think. In fact, I think we'd actually get an error. Oh, we didn't get an error. That's right, because Python has an automatic, whenever you tell it to print an object that it doesn't know how to print, then it will try to create an internal string representation of that object and print the string representation. That is all magic that goes on under the hood. So for well-defined things like lists or whatever, it normally knows how to create a string representation, and it will print the string representation of the list. But if you create your own object, which is very easy to do in Python, then it normally will say, I don't know how to create a string representation of this. So it'll print the memory address at which the object is stored, which is totally useless for anyone. Okay, the last thing that I would like for you to note about this data structure is that it can hold elements of different types.
Would square brackets be interchangeable with parentheses now?
No.
You mean lists? Lists can hold things of different types?
Yes, lists can hold elements of different types. Yeah, if we use parentheses, that would be creating something called a tuple. There's a difference between tuples and lists, and I'll get to it in a minute, but I wanted to start with lists because it's sort of more basic. There's something that's important for you to know about lists, and in fact about variables in general. What I did was I created the list and assigned it to the variable y, and then I assigned the value at the variable that is pointed to by the name y, and I assigned that value to the name fish as well. So what we have now is an instance where there is at least one underlying data object, the list, and there are definitely two distinct names, y and fish. And when I said fish equals y, there are two things that could have happened. One thing that could have happened is we make a copy of the object, and we assign the name fish to the copy of the object. The other thing that could have happened was we didn't make a copy of the object. We just had fish and y be two different names that were pointing to the same object. There is a very simple way to tell which one of those is the case. And that is we change one of the values and in one that corresponds to one name, and we see if it changes in the other. Okay, so here we've got y, here we've got fish. If we want to change a value in the list, we do it with the subscript operator. So y sub 0 should be, what should y sub 0 be? 1. That's right. It's the first element of the data structure that is pointed to by the name y. So if we want to change that value, let's make it green, just to be super, super distinct. Okay. Now we've changed the data structure that is pointed to by the name y, so that the first element is green. And now you know how to change elements of a list by themselves without changing the whole list. Okay, and now we ask, has the value changed for fish? And the answer is yes.